Hey guys, in this video we're going to be talking about exponential functions and comparing their differences to that of linear and quadratic functions. So let's get started. All right, first off, we're going to start by comparing the equations of all of the functions that we have talked about so far this year. So first off, what are the key characteristics of a linear equation? So it's usually in the form y equals mx plus b. You could also have x equals a number, and you could have y equals a number. No matter what, the degree of a linear function is 1. Now when it comes to quadratics, it's a little bit different. We had several different types of equations that we've dealt with. Most common was y equals ax squared plus bx plus c. That was standard form, but we also had factored form where you have y equals a times x minus x1 times x minus x2. Okay? But no matter what, the degree was 2. Now exponentials are a little bit different, okay? So when we talk about exponential functions, our degree here is really weird because it's not a number. The degree is x. So every single exponential function will have an exponent of x, okay? So the most basic is the simple one where it's a times b to the x. You can also have exponential growth, so y equals a times 1 plus the rate at which it is changing to the x. And you can have exponential decay, so it's y equals a times 1 minus the rate that it is changing at to the x. There are also more complicated ones that have to do with compounding interest, but we don't deal with those in Algebra 1. You can save that for Algebra 2. All right, so let's take a look at some equations so that we can determine which type they are. All right, so here are some practice problems. Number 1, we have y equals negative 2x squared plus 5x minus 7. The degree here is 2, so that means this one is quadratic. Number 2, y equals 2 times 3 to the x. The degree is x, so this one is exponential. Number 3, y equals 4x minus 8. Even though it's not there, there's an invisible 1 on that x for its exponent, making it a degree of 1, making it linear. All right, number 4 is that factored form that we talked about on the last page here. If I multiplied these two factors together, I'd get an x squared, giving me a degree of 2, so this one is a quadratic. Number 5 is x equals negative 4. This is a vertical line straight up and down, and because it's a line, or the degree is 1, it is linear. And then the final equation here you see has a degree of x, making this one exponential. So that's how you can determine the differences between their equations. Now let's talk about their graphs. All right, so let's do a little review first. If we're talking about linear graphs, remember they make lines. So you can have an increasing line, a decreasing line, a horizontal line, or a vertical line. Those are all the types of graphs you can have for a linear equation. Now, quadratic graphs, on the other hand, are U-shaped. They can only open two ways, either up, because they're positive, or down, because they're negative. You cannot have a side-to-side U-shape, because then it would not be a function. All right, exponential graphs. Well, they kind of look like an L or a backwards L, but not with a point where you would normally have a point if you were writing an L. It's more of a curve. So it's either starting off very, very slow and then increasing rapidly, or it decreases rapidly and then flattens out at the end. So if it's increasing, the graph starts out pretty flat and then suddenly increases very quickly. If it's decreasing, it goes down very quickly and then flattens out towards the end. Okay, so that is the typical shape of each of these graphs. So let's practice. All right, so for each graph, let's decide if it is linear, quadratic, or exponential. This first one here is a straight line, so it is linear. The second one here is U-shaped, so this one is a quadratic. This one, it's probably hard to see here, but it is flattening out right here, and then it increases very quickly, making this one exponential. Once again, we have a U shape here, so that is another quadratic. This one starts off up top, decreases rapidly, and then flattens out, making this one exponential. And I know this one is definitely hard to see, but here is the line right there. And again, since I said it's a line, this is linear. And that's how you tell the difference between their graphs. Finally, we need to talk about their differences between their tables. So let's start with key characteristics of a linear table. So you are adding or subtract by a constant value in the first degree. Or in the first difference. Quadratic, on the other hand, you are adding or subtracting by a constant value in the second difference. That was the main difference between those two. Now the good news is exponential is very easy to tell the difference between these two because it's no longer adding or subtracting. It's actually multiplying or dividing by a constant factor. So let's take a look at how that looks. So for each table here, we're going to decide whether it is linear, quadratic, or exponential. So if I take a look here, to go from 4 to 0, I would have to subtract 4. But then to go from 0 to 4, I'd have to add 4. So that eliminates linear. This one cannot be linear. Then to go from 4 to 16, I would add 12. And to go from 16 to 36, I would add 20. So let's take a look at the second difference. From here to here, I have to add 8. From here to here, I have to add 8. And from here to here, I have to add 8. This first one is quadratic. All right, the second one here. To go from -9 to -2, I would have to add 5. To go from -2 to 1, I would have to add 3. So again, this is not linear. And if we're adding, it's not going to be exponential either, but we do need to double check. To go from 1 to 0, I subtract 1. And to go from 0 to -5, I subtract 5. All right, to go from 5 to 3, I subtract 2. Oh, I'm not adding 3 here. Hold on a sec. 2, 3. This isn't 5. It's 7. Okay, so then to go from 7 to 3, it's -4. To go from 3 to -1, it's -4. And to go from -1 to -5, it's also -4. So this one is also quadratic. Let's take a look at this one. Now this time, I notice this is increasing rather rapidly, or decreasing rapidly, actually. So I'm going to see if I can multiply by the same amount each time. So if I take -1 and I multiply it by 6, I get -6. If I multiply that by 6 again, I get -36. And if I multiply that by 6 again, I get -216. So this one is exponential. All right, this one's not changing as quickly, so I'm going to try adding. I would add 2 here. To get to 11, I would add 2 again. And to get to 13, I would add 2 again. So this one is linear. All right, this one, I see that it's not changing very, very quickly, but it also is getting into decimal range, which means I'm probably not adding or subtracting by the same amount each time. So let's see if we can find a common factor. To go from 4 to 2, I would divide by 2 or multiply by a half. To go from 2 to 1, I once again would multiply by a half. And if I look, you would end up multiplying by a half all the way down this table. So this one is going to be exponential. And finally, over here, to go from -7 to -4, I have to add 3. -4 to -1 is add 3. -1 to 2 is add 3. And 2 to 5 is add 3. So this one is linear. All right, one last thing we need to talk about, and that is determining if a scenario that you are given, so like a mini word problem, is linear, quadratic, or exponential. All right, so for a linear scenario, you are typically given a starting point. And then something is added or taken away in a constant way. Okay. Quadratic is a little bit different. You are still given a starting point. But then one of two things is going to happen. Either something drops or falls, or velocity is used to project something somewhere. Okay. Now, when it comes to exponential, you have a few things that could be occurring. Okay. So you're usually given a starting point. That's a common theme here. And one of two things will occur. If it is a simple exponential, something will double, triple, etc. That tells you that it's increasing quickly, or it could be decreasing. Or you are given a rate or a percent at which something is changing. One of those two things will happen. So let's take a look at some scenarios. All right, so what I did here was I took the same idea and turned it into one of each type. So for this first one, it says, you recently purchased a new car. Each month, you pay a car payment of $400 until you pay off the car loan. Now, what was not given here was how much you paid for the car, but that's not necessarily the most important part. What's most important is that you are paying $400 each month, okay? So that is being taken away from what you owe every single month, so it's constant. That makes this one linear because you are subtracting $400 every single month. Okay. Number 2, the new car that you purchased decreased in value each year by 10%. So here's the key here. It's that 10%. That makes this one exponential, because you would be multiplying by that 0.10 to find out how much you are losing each year. Finally, 15 years later, the car that you purchased no longer runs. You decide to launch it out of a catapult. The car starts at a height of 50 feet and it is launched. It hits the ground 10 seconds later. I mean, if you're launching something, it's going to go up, 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 and then eventually come back down and hit the ground just like it said, making this one quadratic. And that's it. That's the main difference between linear, exponential, and quadratic.